Okay, the wording of this problem is a little confusing, especially this last sentence, at extremity of diameter opposite to extremity of chord. I'm not quite sure what that means, so I'm going to take a stab. Here's your square ABCD. Here's a circle with center at C. It passes through point A, and then I've drawn a line through points B and D, and that line intersects the circle at these 2 points, and then I've kind of drawn with dotted lines the radius from C out to here and from C out to this point of intersection. And I think what they're asking for is the size of that angle right there. Okay. Now, you can do this by letting the side of the square equal A or V or some variable, or you can do it starting with a specific value. And if I share my screen and go to Desmos, you'll see that I've done this with the letter A here for the side of the square. But in all cases, if you focus on this angle right here, angle A, it stays at 120. So I'll move way out to here, and I'll go down and look at angle A, and I'll bet it's still 120. There it is. So the question is, how did I come up with that? And there's different ways to do it. One of the keys is that this radius right here has to be, well, I'll use number 2 for a specific example, has to be 2 radical 2. Because this segment right here from C to A is the hypotenuse of a 45-45 right triangle. And the hypotenuse is radical 2 times a short leg. Now, how can we find the size of this angle? Well, one way to do it would be to find the distance from, let me call this point P and this point Q, would be to find the distance from P to Q, and then we would know, we would have a triangle that looks like this. 2 radical 2, 2 radical 2, those are the 2 radii right here. We could find the distance or the length of this segment if we knew the coordinates of P and Q. I wonder how we can do that. But then if we, let's just put a big D here for the distance from P to Q, then we could use the law of cosines to find this angle right here, cosine of theta. So how can we find the coordinates of P and Q? That is the question. One way to do that is to find the points of intersection of this straight line with the equation of the circle. And that circle has an equation, x minus 2, the quantity squared, plus y minus 0, the quantity squared. And the radius we know is 2 radical 2, so 2 radical 2 squared is 8. There's the equation of the circle. The equation of the red line is y equals x. So we want to solve this system for x, and the x coordinate and the y coordinate of these points of intersection will be equal because they're on the line y equals x. I should stop sharing here. So substitute x in for this y, square this binomial, x squared minus 4x plus 4 plus x squared, substitution, equals 8. Solve that equation for x, and you've got the x coordinates. of points P and Q. And then once you've got those, you got Y, and then you can find the distance between those 2 points. You've got D, and then use the law of cosines. And I'm not going to go through the law of cosines here. Another way to do this problem probably would be to find the slope of CP. And then this angle right here would be the inverse tangent. And then this angle would be 90 minus this angle. And I'm guessing that these two angles would be congruent. And it would be 90 plus this plus this. Okay, so I'm going to stop recording. That hopefully gave you some ideas. If you have any questions, post a comment.